Hello, welcome to this session on optimizing your data lifecycle, where we're going to talk about delivering the maximum value with your data at the lowest cost, about how to balance storage cost and search performance. My name is Sajjad Ahmed, and I'm the product management lead for Elasticsearch. With me today is Yulia Cech, a senior engineer with the stack management team in Kibana. Here's a brief rundown of the agenda. First, I'll talk about the typical data lifecycle stages for time series data in an organization. Then we'll take a look at how the Elastic Stack handles these stages for you with the various data tiers we provide. And we'll cover some of the trade-offs that each tier offers. This will follow with an explanation of how we've actually been able to build the new lower cost data tiers for longer term data storage with searchable snapshots, a powerful capability that brings your object store to life. Then from there, Yulia will dive right into a demo to show how easy it is to set up your index lifecycle management, or ILM for short, policies to manage the transition of your data through the various stages of its lifecycle. So let's start with the typical data lifecycle stages. The Elastic Stack is very commonly used for ingesting, storing, and searching time series data, such as logs, metrics, traces, security events, and so much more. The problem with time series data, though, is that it grows in size very quickly. If you ingest a terabyte of data per day and you keep it for a week, that's 7 terabytes. And if you're required to keep that data for 5 years or more, we're very quickly talking about petabytes of data. It typically isn't cost effective to store all of that on the most expensive hardware available. So that's where a tiering strategy can become very useful based on the lifecycle stages the data passes through. When the data is fresh, it's being used heavily. This drives your alerting, anomaly detection, and your DevOps or security workflows. When you're investigating an incident, you need access to all the relevant data, fast, to find and fix the issue. When an attacker compromises a host or an application, your ability to respond quickly often determines the significance of the breach. This is what we'll call the high relevance stage of your data, if you will, where searches are very frequent and require super fast response times. But either as the data ages or based on other categorization rules you may have, it's used less frequently. An example, how does this spike compare to last month? Has this user logged into a restricted system in the last 2 months? That's what we'll call the medium relevance stage, where searches are less frequent, but still require a fast response. Then the data reaches the point where it's either driven by company or legal requirements as part of your annual audit, proving you can pull back data from a year ago, or for serious incidents to do an exhaustive search. Here it falls into low relevance. Searches are occasional and slower response times are typically quite acceptable. Eventually, the data makes its way to deletion or archival into another system. So how does this translate to what the Elastic Stack provides? Well, let's take a look. We've had support for data tiers for a while, making it easy for you to store and search your time series data. We started with the hot and warm tiers, where hot is generally for fast machines with SSDs for data at the high relevance stage, and warm is for lower cost machines with spinning disks for the medium relevance stage. Index lifecycle management provided some conventions to make it easy to manage data across the hot and warm nodes, and then made it easier by introducing a new node role that you could just assign your nodes to. This made the job of admin users much easier, and it formalized the whole definition and use of data tiers. Then, with the arrival of searchable snapshots, the exciting capability that literally brings object stores such as S3 to life, we've added 2 newer lower cost data tiers to the Elastic Stack to help our users more effectively balance performance, cost, and data retention needs. The cold tier is for data that's still in the medium relevance stage, but is accessed slightly less frequently than in warm and has become read-only. With the cold tier, you can store up to twice as much data on the same amount of local storage. Then there's the frozen tier for low relevance data, which decouples compute from storage to leverage S3 and other object stores to store and directly search up to 10 to 20 times as much data for the same amount of local hardware as in warm. So what does this all mean for you as a customer? It means you have options available to balance the cost of storing data with the expected search performance needs of your users. The hot tier with high performance CPUs and SSDs is the most expensive and returns query results fast in milliseconds. The warm tier is cheaper, but search performance may drop down to seconds or so. The cold tier can store up to twice as much data as the warm tier for the same cost, but with very little impact to performance. And then finally, the frozen tier can store up to 20 times the data that the warm tier does, but performance can drop down to minutes if the data isn't cached. For all of this, you can use ILM policies to automate the transition of data from one tier to the other. So here's a more concrete example, showing you how your total cost of ownership goes down as you begin adopting more of the lower cost tiers. For a typical self-managed Elasticsearch cluster in AWS EC2 with, say, 1 terabyte of daily ingestion and a total retention of 365 days. So if you use just hot and warm nodes, you're paying about $52,000 a month in infrastructure costs. This is primarily due to the number of nodes that you need to support the data in both your hot and warm tiers. As you start replacing warm with cold, your cost drops by about a third because you need fewer nodes to support the same amount of data in cold. If you use hot, warm, and frozen, your cost has dropped by half in total because the frozen tier simply just needs far fewer nodes to support the same amount of data. And then if you get down to just using hot and frozen, you could see your total cost of ownership drop by up to 75%. So you could finally meet your long-term data retention requirements for regulatory compliance reasons, now without having to break the bank. And you can further open up new use cases with access to far greater amounts of data for things like security lookbacks and performance comparisons. Okay, let's switch gears just a little to understand what Searchable Snapshots is all about and how it powers the cold and frozen tiers. So we have, of course, had support for snapshots for a while. Snapshot Lifecycle Management, or SLM for short, is a great way to back up your data into S3 or any other low-cost object store. You're able to successfully manage the large volumes of data that are continuously being ingested into your clusters without having to break your bank accounts. You can retain your data for the long haul without having to store it all on expensive, high-performant hardware where only your most frequently accessed data needs to be located. You can further meet the regulatory and compliance requirements for data retention this way, whether it's 2 or 10 years or something in between. The issue, until we introduced searchable snapshots, however, was that these snapshots simply just weren't searchable. You had to restore the data first into your higher cost hardware before it could be accessed, which affected both the user experience and time to value. So we introduced searchable snapshots. Your snapshots could now be directly queried and become an active part of your searches. And that opened up a slew of new possibilities and use cases for you, whether it's looking up historical data for audits, security investigations, or performance comparisons. Searchable snapshots has you covered. They're the underlying capability that power the lower cost data tiers that we've added to the Elastic Stack to more effectively balance performance, cost, and data retention needs. So how did we use searchable snapshots to create these lower cost data tiers? Well, in the hot and warm tiers, we have a replica for every shard of data. And the replicas are stored locally on the same kind of hardware as the primary shards. In the hot tier, that's typically on SSDs, and in the warm tier, it's on a spinning disk. In the cold tier, what we've done is to separate replica shards from their primary counterparts. Your primary shards are still running on local disk, as in your warm tier, but the replicas are now part of the snapshots in S3 or a similar object store that your indices are backed with. So we've essentially doubled the capacity of your cold nodes and effectively halved your storage costs in comparison to the warm tier, and all with very little impact to search performance, as your primary data is still stored locally. In the case of a machine failure, we'll automatically recover for you using the snapshot in S3. And because of deep improvements that we made in Lucene and Elasticsearch, we can begin searches against the snapshot within seconds, long before a restore from snapshot to build a local cached copy could even complete. The frozen tier is powered completely by searchable snapshots. When you run a query against the frozen tier, you're fetching data directly from the object store. And you're fetching only those pieces that you need from the object store and storing it locally in a cache. If you need to run queries against that same data again, you just run against the cache for optimal performance. Searches that just use the cache have performance not too far off from what you get with the cold tier. As the cache builds up with time, once it runs out of space, we just recycle the old data for new data as more data is fetched from the object store. The other neat thing is that we've built a number of features in the Elastic Stack to provide the best possible experience around these slower running queries, be it async search or improvements to query efficiency, such as skipping unmatched indices, stopping the search immediately when enough matches are reached, and block max WAND for text search. We've actually made optimizations at the Lucene level too, to ensure searchable snapshots run as fast as possible by only retrieving those subsets of the snapshot index that are actually needed for the search to complete. Together with all the other efficiency improvements we've made, this provides the best possible performance and user experience. There's still a drop in performance over the warm or cold tiers, no doubt, but with a significant expansion of your data reach for the same cost. So that's the data tiers in a nutshell. Now, let me hand it over to Yulia to show you how to use ILM to set up your data lifecycle policies. Yulia, go ahead.
Thank you, Sajjad. Hello, everyone. My name is Yulia Cech, and I'm a software engineer on the Kibana team. And today, I would like to configure an index lifecycle policy together with you for a concrete example. First, let's navigate to Index Lifecycle Management app, or ILM. It is located in the Stack Management section. And here you have a lot of apps that help you configure your Elasticsearch cluster. So in the data section, let's click on the Index Lifecycle Policies link, and you will see ILM policies that already exist in your cluster. Well, some of them you have created yourself, and some of them are created by the Elastic Stack. We are working hard on shipping useful out-of-the-box ILM policies that you can apply to your data straight away. So look out for those in the future releases. Now, let's create a new ILM policy by clicking the Create Policy button and providing a descriptive and informative name, like, for example, Audit Compliant Data Retention. Now, imagine we have some web service logs that are being ingested in our cluster. And we have this compliance policy in place that prescribes that we keep this data for 7 years for audit purposes. Now, as you can see in the visual policy summary, by default, a new policy keeps the data forever in the hot phase. Well, that would be very efficient in terms of searches and visualizations, but that would be very, very expensive. And we also know that we mostly search the last 10 days worth of data in our cluster. So what we want to do is we want to keep the data for 10 days on the hot tier, and then 10 days after rollover, we want to move the data to the warm tier. If you're wondering what rollover is, it is when a new write index is being created for a data stream or an index alias. If you're not sure about your configuration, we recommend you to just use the defaults. That is, a new index is created when the previous index becomes 30 days old or it reaches 50 gigabytes in size. Now, back to the warm phase. Let's enable it and fill out the timing input field with 10 days. So now the data will be moved to the warm tier 10 days after rollover and stay there forever. Well, we don't want this because we want to move data along to less expensive and less performant hardware. We also know that after about 1 month in the cluster, the data becomes even less relevant for our search results. So we want to enable the cold phase, and we want to fill out the timing input field with 30 days. Now, let's recap. The data is being ingested on the hot tier. It is at this point being searched very frequently, and then 10 days after rollover, it is moved to the warm tier. And then it spends 20 more days on the warm tier, and then it is moved to the cold tier. Now we know that about after another 2 months, the data becomes less relevant for our business, for our search results, but we have this compliance policy that says we have to have access to the data for another 7 years. And we need, for example, to create an audit report out of the data. So even though the cold tier hardware is optimized for cost savings, it would still be very, very expensive to keep all the data on the cold tier because of the sheer volume of data. And now, as Sajjad said, we could solve this problem with searchable snapshots, because searchable snapshots allow us to leverage the low-cost object storage, and we have access to almost unlimited amount of data. So let's enable the frozen phase, and let's fill out the timing input field with 90 days. That means that 3 months after rollover, the data will be converted to a searchable snapshot, and it will be transferred to your favorite object storage provider. Here I select a repository that I registered earlier. And if you're using Elastic Cloud, a repository will be automatically created for you, and it will be registered in your deployment automatically, and the form will pre-select the value for you. And so now, at the fraction of the cost, we can keep the data for 7 years. And after that, we are finally ready to delete the data completely from the cluster. Well, not completely, because we still be able to create a backup of the data before deletion. So now let's have a look at this toggle that is displayed in the last active phase of your ILM policy. Currently, it indicates that the data will stay in the frozen phase forever. Let's change that. And let's fill out the correct timing value, 2,555 days. That means that all the data that is controlled by this ILM policy will be deleted from the cluster 7 years after rollover. And so now, if you want to create a backup of your data, you can do it right here by selecting a snapshot policy that will create a backup of your logs. And remember, the snapshot here is not the same as the searchable snapshot that we used in the frozen phase, because the snapshot created here, it cannot be searched. But if necessary, you can restore the data from this snapshot back into your cluster. And now, as you can see, the audit compliant ILM policy is configured. So we can just click save, and we are done. And before we wrap up, I would like to show you a couple of tips when using this ILM UI. First is that you can use searchable snapshots, not only in the frozen phase, but in the cold phase. Just toggle this switch to convert your data to a fully mounted index. And as you can see, snapshot repository field is already pre-filled for you. We're using the same snapshot repository that we used in the frozen phase. And for some rare use cases, when your data becomes stale really, really fast, you might want to use searchable snapshots in the hot phase as well. So there is an option to do it right here. Okay, next tip. Sometimes you want to clone your ILM policy to maybe do some minor modifications to it. To do that, just click the toggle to save the policy as a new policy, provide a new name, and click save. And that way you created a copy of your ILM policy. And the last tip, sometimes you want to automate your Elasticsearch cluster configuration. Maybe you are creating a lot of ILM policies or editing a lot of ILM policies, and you want to create a script for that. So open ILM policy for editing and scroll down, click the show request button, and you will see the exact code for your Elasticsearch request for this policy. You can copy it and then paste into a script or into DevTools console. Okay, and to summarize this demo, there are only two controls that you need to keep in mind when you are configuring an ILM policy. The first one is this toggle to enable or disable a phase in your ILM policy. And the second one is this timing field to configure your phase duration of your ILM policy. And that's it. As you can see, it is very easy to configure an ILM policy in your cluster. Thank you, everyone. And now back to Sajjad.
Thank you, Yulia. That was a great demo. Now, to summarize, we've talked about how you can optimize your data lifecycle to deliver the maximum value to your users and at the lowest cost. Using the various data tiers that we provide, you can balance storage costs with search performance for the various stages your data goes through over a period of time. What's most interesting are the new cold and frozen tiers that significantly expand your ability to store and search data at far lower costs than ever before. Thanks to the exciting searchable snapshots capability that we've built that enables you to directly store and search data in a low-cost object store such as S3. Finally, as Yulia showed, you can set up your lifecycle stages very easily by defining the appropriate policies in ILM. With that, thank you for joining us and listening to this session. I hope you found it useful.